from Marcus's Academy. Thank you for joining me in this video. In today's video, we shall treat Pascal's triangle, how we can actually establish the pyramid formula. Actually, the triangular formula is infinite. Okay, so let us do an abstract. All right, suppose we are to establish, let's say we have our topic is Pascal's triangle. Okay, actually the definition of this triangular formula is just an array of what numbers, okay, where the extreme numbers are what 1, though there are 0 entries outside each of the Pascal's what triangle, outside each of the rows. Okay, so now we can actually establish the triangle in this way, using A to be the first element of the triangle. Okay, we have B and C to be the second what entries, that is the second row, 1 entries. Okay, now actually we can have the second row to be B plus C. All right, to have that is B plus C. Okay, or we can actually have it in this way. Let's clean. Okay, for us to have space. Okay, so we can actually have B plus C to be E. We are at the extreme of this row 2. We have D. The other extreme we have what? F. Okay, we can actually sum these two, B plus E, to have H. Okay, we fix G at this extreme here. Summing E and F, we have I. Okay, and we fix J at the extreme. Are you seeing the expansion? How I'm just having a triangle. Again, when I sum G and H, I have L. At the extreme of this row, I have K. When I sum H and I have M. Okay. When I sum I and J, I have N. At the extreme of the same row, I have what? 0. That is O. Okay. All right. So mind it is A, B, C, D, E, F, G, H, I, J, K, L, M, N, O. Right? Okay. When I sum these two together, I have Q. Okay. Having P at the extreme of this row. Summing L and M, I have R. Summing M and N, I have S. Summing T, right? This should be T. Okay, N, sorry. N and O, I have T. Then I have at the extreme here U. Okay, and in that way. So do you see how actually I'm having the triangular or the pyramid word formula? Do you get? So here is what? 0th row, row 0, row 1, row 2, row 3, row 4, R5. Okay, so we can have R6, R7, R8, etc. Okay, so it is infinite. The establishment of the formula is what? Infinite. Okay, so it shows that here, like I said, okay, one of the features is that outside every row of the formula we have what? 0 what? Unit digits. Okay, so it means we have 0 here, 0 here. Okay, 0 here. Here we have 0, 0, so there are zeros everywhere. You get me? Around the Pascal's what? Triangle. But those zeros are what? Invisible. So you don't see it. That is why we normally what? Omit the 0 digits. Alright, let us clean this, okay, and use what? Numbers. So the purpose of this video is for you to learn how you can actually establish what? A pyramid formula of what? Numbers, okay? Which we call Blaise Pascal's what? Triangle. Though this triangular formula was actually or originally established or created by Pierre de Fermat, okay? Well, he worked closely to Pascal. Don't know what happened. Okay, actually, Pascal was the one that popularized the pyramid formula. All right. First of all, how we can establish this Pascal's triangle is for us to create a pyramid of 1. When I say pyramid, I mean something of this nature. Okay, write it well. Something of what? This nature. That is just a triangle, like Egyptian word pyramid. Okay, so clean this. All right, so a pyramid of 1 is given as, you write 1 first. You write 1 at the 2 downward extreme of what? The upper one. Okay, so we note that we have zeros outside. Okay, how do we have this one here? It is gotten by what? Summing what? These two. 0 plus 1, we have what? 1. 1 plus 0, that is this 2, we have what? 1. That is how we actually have what? The ones that form our what? Row 1 entries. Okay, so but to make this clean it, for us to have just have what? A pyramid of what? 1. So we have 1, 1, 1. This is row 0, row 1. Okay, we proceed. Now we sum this from row 1. We sum the 2 ones to have what? 2. That is 1 plus 1, which is what? 2, right? We fix 1 at the extreme. Okay, yeah, because we know that 0 here, this invisible 0 here, summing 1 will give me what? 1 here, and the same thing happens here. Okay, so but we don't actually include the 0. That is why we omit it. So let me clean that. All right, so for us to have our row 3 entry, I have to sum 1 to 2 to have 3. I fix 1 here. I have to sum 2 and 1 to have what? 3. I fix 1 here. Are you seeing how the triangle is being formed? Okay, so for me to have my row 4, I will sum 1 and 3 to have what? 4. Sum 3 and 3 to have what? 6. Summing 3 and 1 to have the same 4. Fixing 1 here, 1 here. So there are 1s at the extreme, at the extreme rows of Pascal's triangle. So I have my row 4. For the row 5, I sum 1 and 4 to have 5. 4 and 6 to have 10. 6 and 4 to have 10. 4 and 1 to have same 5. Then I call that my 5th row, row 5. Okay. So you fix 1. Okay, at the extreme. All right. Then row 5. Okay. So we can actually, mind you, in our abstract, okay, we stopped at row 5. So we can actually stop at row 5 here. We can still proceed, okay, to form our what? Row 6. All right. All right. Okay. But it doesn't really matter. Okay, the main thing is that you have seen how you can actually create a pyramid word formula of what? Numbers. Now, like we say that at the entries of what? A Pascal's triangle, we have what? Unity numbers, right? Okay. There are some observations, okay? We can actually use Pascal's triangle to establish or find a binomial word series or binomial expansion. Okay, we can do that. Okay, but that is not the purpose of this video. Okay, but it is one of the observations. Okay, each row of the Pascal's triangle actually depicts the coefficients of what? A binomial. But that will be done maybe in our next video. Okay. Again, there is one unique observation of this Pascal's triangle. In each row, like row 2, row 0, for instance, okay, we can have 2 raised to the power 0. And in indices, 2 raised to the power 0 is 1, right? Okay. It means that when we sum every entry of this row 0, we shall have what? 1. Okay. So for row 1, we shall have 2 raised to the power 1. When we sum every entry of row 1, we shall have 2. 2 raised to the power 1 is 2, right? So 1 plus 1 is 2. From row 2, we can have 2 raised to the power 2, which is 4, right? When we sum every entry of what? Row 2, we shall have what? 4. 1, see it, 1 plus 2 is 3, plus what? 1 is 4. 2 raised to the power 2 is 4. That is 2 times 2 is 4, right? From our row 3, we can have 2 raised to the power 3. Meaning that when we sum all these numbers, okay, we shall have 8, okay? All these numbers of what? Row 3, we shall have 8. 2 raised to the power 3, 2 times 2 times 3 is what? 8. From row 4, we have 2 raised to the power 4. summing all these numbers, okay, 1 plus 4 is 5 plus 6 is 11 plus 4 plus 1, okay, gives a number, okay. So 11 plus 1 is 12 plus 4 is 16, right? So 2 to the power 4 is 16. In the same way, we can have this 2 to the power 5. When we sum every entry of this row 5, we shall have a particular whole number, and that is what 2 to the power 5 will give us. In the same way, okay, when we proceed to row 6, row 7, etc. Okay, so this is one of the, or among the greatest observations of Pascal's triangle. Again, we can actually see or arrange Fibonacci sequence, okay, in this triangular formula. And again, we can actually find the power of 11s, okay, which we call magic 11 from this Pascal triangle, okay. For instance, 11 raised to the power 0 is equal to 1. We find that at our 0th row. Again, 11 raised to the power 1 is 1, 1. That's 11. We can find that at our row 1. Again, 11 raised to the power 2 is 1, 2, 1. We can find that at our row 2, 1, 2, 1. Again, 11 raised to the power 3 is 1, 3, 3, 1. We can find that at our row 3, 1, 3, 3, 1, okay? In the same way, 11 to the raised to the power 4, well, whatever it gives you, you can find out in our row 4, 1, 4, 6, 4, 1, okay? Now, when you come to 11 raised to the power 5, okay, we have to do some manipulation here, okay? But it is not the purpose of this video. The purpose of this video is for us to know how we can establish a pyramid formula of ones. Alright, sorry, not ones, but a number of a pyramid formula of numbers, okay? So in the next video, I shall show us how we can actually find a binomial coefficient, okay, from this Pascal's triangle, okay? So we can actually expand a binomial series, okay, or find a binomial expansion using Pascal's triangular formula, okay? Suppose we don't want to use the binomial formula, okay? Then maybe in the other video, I will now use, okay, show us how we can actually multiply out 11s, okay, or raise the 11 to a particular number, okay, and find the numbers from the Pascal's triangle. Hope you found this helpful. Please do subscribe to my channel. Thank you for watching.